Okay, these are the notes for 11.8. In the first problem, you're not going to be able to really do the bottom if you're not in class. Just a quick review of probability. When you consider, I guess, the winner, what is the probability you will pick a red jelly bean if you have 8 red and 10 blue? Your, quote, winners, I guess you could call them, would be the red, so that's your numerator. And your denominator is how many options you have to choose from. And there are 18 total jelly beans. And then we reduce that to a 4 to 9. So you have a 4 out of 9 chance of picking a red jelly bean. All right, so now we're going to kind of look at that in terms of geometry, segments, areas, and such. So every 10 minutes, a bus pulls up to a hotel and waits for 2 minutes while passengers get on and off. Then the bus leaves. If a person walks out of the hotel front door at a random time, what is the probability that a bus is there? So I just put some times in here because I think that's a little more concrete for a lot of you. So if a bus arrives at 12 o'clock, it would sit for 2 minutes. That's till 12:02. Okay? And then it would leave. And it says in the beginning, every 10 minutes a bus pulls up. So at 12 o'clock a bus pulls up, at 12:10, at 12:20, and so on and so on. So if we look at this entire segment, you could look at the whole thing, but I'm hoping you're seeing there's kind of a repeat here. I have a total segment between buses of 10 minutes. So probability that the bus is there, what is the part that's the winner? And that would be this 2-minute block in here. So probability the bus is there, out of the 10 total minutes between buses, between one bus arriving and the next bus arriving, the winning time would be 2 out of 10 minutes. So you would have a 1 in 5 probability that a bus would be there if you walked at a random time out the door. In the next one, we have a bullseye. So you can probably do this one on your own. Consider, are you looking at area? Or are you looking at circumference? So push pause and try this one on your own. All right, what I'm hoping you did is you found the area of the blue. The 3 corresponds to the entire radius, and the area of the red. And you're looking for the probability it'll hit the red. So I'm going to take the area of the red, divide it by the area of the blue, and simplify it. So you have a 1 in 9 chance of hitting the bullseye. Now, if I said what is the probability of hitting the white, please remember you wouldn't just do a straight area of the white. You'd have to have the area of the white and subtract out the red area. So please be careful on those. So again, the correct answer for the probability the arrow hits the red bullseye would be a 1 to 9 ratio. And again, we're assuming you would hit the board at some point. You wouldn't miss the board. All right, over here again is another problem. Please try this and then come back, okay? All right, over here, I took the congruent sections. You can see I marked them in either blue or red. Since these are the smaller ones, I kind of called each of those 1. So one red section is 3. And so I've then marked all of these 3. So from A to F is a ratio, an entire length of 9. And we're looking for between B and C. B and C is just one section of the total 9. So the probability of selecting a point between B and C would be a 1 out of 9. Between C and F, okay, well, again, the whole thing is 9. From C to F would be 3 plus 1 plus 1, which is 2. So you would have a 5 out of 9 probability of plotting a point between C and F. All right, one more problem. I know this one's a little more difficult, so give it a try. I'm doing a video. And then come back. All right, over here, you'll see I have this point X, and I can move it through a lot. So if I maybe moved it here, A to X would be 1. We want it to be greater than BC. What I did again is I found the smallest portion, which in this case was DE. I called that 1. CD was 2 DEs, so that was 2. CD and AB are equal, so A to B is also a 2, that distance there. And BC was 2 ABs, so if AB is 2, BC is 4. And I kind of put this red point here at 2 because that's the point. If I move the X to here, 2 plus 2 is 4. That's where A to X would be equal to B to C. B to C is 4 if I put it here. So anywhere here is not good. If I put the X anywhere in here, the distance from A to X is going to be less than the distance from B to C because it's going to be less than 4. However, if I put X anywhere over here, I'm good. It could be 5, 7, it could go all the way over here. So this section is bad, 4, section length 4 is bad. The section length that's good is 5. So your answer here would be 5 out of 9. There are 5 out of 9 kind of places you could place the X so that AX was greater than BC. And that concludes the notes for 11.8.